So let us do the first example. You can see a simple T network and you have to find the Z parameter. So either you can directly use the formula that we have discussed earlier, or you can just apply KVL equation. So let me call this as V1. If you don't remember the formula, it doesn't matter. You just have to remember the concept. So we just write the KVL equation in input and in the output, and we will get the Z parameter. So what will be the input, the KVL at input? V1 will be equal to 20 into I1 plus 40 into I1 plus I2. So we will get V1 is equal to 20 plus 40, 60 I1 plus 40 I2. So this is your equation 1. And similarly, you will get V2 is equal to 40 I1 plus 70 I2. This will be your equation 2. So just by comparing these two equations with the standard Z parameter equations, this will be Z11, this will be Z12, this will be Z21, and this will be Z22. So your Z parameter will be, it is written like this, 60 ohm, since all are impedances, 40 ohm, again 40 ohm, and this is 70 ohm. So this is your answer. Now you have a pi network given and you have to calculate the y parameters. So for solving this equation, this type of question, or even the previous question, you can solve it using three methods. The first method we just discussed here. Here you have written KVL equations and just compared it with the standard equation for Z parameter. Here also you can write KCL equations here, at here, and here. Since this is V1, this is V2, this is I1, this is I2. So this can also be V1, this can also be V2. So using KCL equation, you can write this equation which will be relating V1, I1, and I2. And then after rearranging, you will have to compare these equations with the standard y parameter equation, and you will directly find the values of y parameters. Other way is that we just discussed the pi network, where you found that y11 was nothing but ya plus yc. I think it was that. Sorry, ya plus yb, and this was the admittance of ya here on this branch, and then admittance of this common branch was yb, and the admittance of this branch was yc. So you can use the direct formula which you calculated earlier. Similarly, y22 was nothing but yc plus yb, and y12 is equal to y21 was equal to minus of yb. So this was the formula we calculated for pi networks. And you have to see that these values are written in ohms. So these are not the admittance values, these are resistance values. So the corresponding Ya will be 1 upon 4 because it will be reciprocal of this. The corresponding Yb is equal to 1 by 2 from here, and the corresponding Yc will be 1 by 8. So now you can directly put these values here, and you can find the Ya, Yb, sorry, Y11, Y22, Y21, and Y12 values. Also, there is a third method where you can individually use the formula of Y11. So for Y11, what is the value of Y11? From the definition of Y parameter, it is I1 upon V1 when V2 is equal to 0. It is a short circuit parameter, right? So in this case, you have to draw a circuit which is which has its output as short circuited, and then calculate the ratio of I1 and V1, and you will subsequently get the value of Y11, and similar to the others. So let us calculate one of these things using this formula. So let me draw a circuit where output is short circuited, because we have to take V2 is 0. So we will get a circuit like this. Now, since the output is short circuited, there will be no meaning of this branch. So it will all be considered as a short circuit. This is 2 ohm, this is 4 ohm. this is your I1, and this is your voltage V1, which is between this and this, right? So what we have to calculate? We have to calculate the ratio of I1 upon V1. So we can very easily do it by calculating the value of V1 in the form of I1. So let us first calculate the currents in these individual branches. So let me call it as I1 dash and this as I1 double dash. So let me calculate I1 dash using the current division rule. It will be I1 into 2 divided by 4 plus 2. So it will become I1 divided by 3. So your I1 dash is I1 divided by 3. So can you tell me what is the value of V1? It is I1 dash multiplied by 4, which will be I1 into 4 by 3. So the value of V1 is nothing but I1 into 4 by 3 under the condition V2 is equal to 0. So can you calculate the ratio I1 upon V1? Yes, very easily. You just use this formula. So you will get I1 upon V1 is equal to 3 upon 4. Yes, under the condition V2 is equal to 0, and this is nothing but your Y11 value. Similarly, you can calculate all the values of Y parameter using this method. And I already told you the other two methods. The first method was to calculate the equations of I1 and I2 in the form of V1 and V2 and compare with the standard KCL equations of Y parameter, and then you can directly find. And the other one is you can just use the pi network formula to directly calculate, but in this case you have to remember this formula. And the last one is by going the individual definition of these Y parameters. So similarly for H parameter, similarly for Y parameter, similarly for ABCD or any parameter, you can apply all these three type of things to calculate your parameter values. So let me write all the answers. The unit of admittance can be either mho, or we can also call it as Siemens. So Y11 is this, Y12 and Y21 will be same obviously, and Y22 is this, right? Let us move to the next example. Now in this example, we have to find the hybrid parameters for this particular network, and we will go to the standard equation comparing method, or rather we should go to find the individual hybrid parameters using their definitions. So we have these two standard equations for hybrid parameters, and this is your voltage V1, this is your current I1, this is your voltage V2, this is your current I2. So use the standard notations. All the current should be coming inside. So can you tell me what will be the value of H11? It should be V1 upon I1 when V2 is equal to 0 from this equation. So you have to make a circuit where you have to short circuit this and then calculate the value. So let us do it. So our circuit will become like this. So this is our V1, this is I1, this is 2 ohm, this is 3 ohm, and this is 6 ohm. So we have to calculate the ratio of V1 upon I1. So we have to represent this voltage V1 in terms of I1. So let us use the simple current division rule. Let me call it as I1 dash. So I1 dash will be equal to, using the current division rule, I1 multiplied by 3 divided by 6 plus 3. So we will get I1 divided by 3. So I1 dash is nothing but I1 divided by 3. So can you tell me the value of V1? So V1 will be nothing but I1 into 2. So V1 will be, using the KVL, if we want to write the KVL in this part, V1 will equal to I1 into 2 plus I1 dash into 6. So let us write I1 dash in terms of I1. So we will get I1 into 2 plus I1 upon 3 into 6. So we will get 4I1. V1 is equal to 4I1. So obviously V1 upon I1 is going to be equal to 4. And this is basically in terms of ohms. So what is this? This is nothing but your H11 value. So your H11 value using this came out to be 4 ohm. Now let us calculate H12. And what is the value of H12? It is basically the division of V1 with V2 when I1 is 0. So I1 is equal to 0 means you have to make this circuit open circuit, right? So if you have made this circuit open circuit, let me see what the circuit look like. So this is open circuit, and you have V2 here and the current I2 here, and there is no current I1 entering, so that it will have no effect. And this whole I2 current will be going through this. This is your 3 ohm and this is your 6 ohm. And there will be no meaning of this 2 ohm resistor because there is no current in it. So what you have to calculate is you have to calculate V1 upon V2. So what is the value of V1? V1 will basically be the voltage between these two terminals. So what is the value of V1? V1 is nothing but, since I2 current is going into only this branch, it will be I2 into 6 ohm. And what is the value of V2? Apply KVL in the output branch. So you will get I2, V2 is I2 into 3 plus I2 into 6, which means 9 I2. So you have got the value of V1 and V2 in terms of I2. So you can now very easily calculate H12, which is equal to V1 upon V2 at I1 is equal to 0. What is V1? It is 6 I2. And what is V2? It is 9 I2. So you will get 2 by 3. And what will be the unit? It will be unitless because both the numerator and denominator are voltages. So you will have H12 as 2 by 3. Similarly, you can calculate the values of H21 and H22 also. So I'm just going to write the final answers. So finally, we will get these values as answers, and you can verify it by solving it by yourself. Let us move to the next example. So we have to find the value of B and D, which are transmission parameter or ABCD parameters. So we have to find the value of B and D for the given circuit. So let us first quickly write the ABCD parameter equations. So these are our ABCD parameter equations. So we have to find B and D. So what will be the value of B? B will be nothing but minus V1 upon I2 when V2 is equal to 0, and the value of D will be minus I1 upon I2 when V2 was 0. So in both these cases, we have to make the V2 0, and this was your V2, and if you want to make it 0, so what you have to do is you have to short circuit these two terminals, right? So let us make a modified circuit. So when you short circuit, there will be no meaning of this 4 ohm voltage source because all the current will be going through the short circuit. So all you will get is, and also when V2 is 0, and you can see that in this circuit, this current source is dependent on V2. So if V2 is 0, what will happen to this current source? It will be 0. So it means it will be open circuit. So you are going to get a very simple circuit. This is your 4 ohm. This is your dependent voltage source whose values is V1 upon 5, and then there is a short circuit, and then this circuit completes. So this is your 4 ohm, this is your V1, definitely V1, and this is your current I1. So in this modified circuit, this is your current I1, and even if this circuit was short circuited, you will take this current as I2 only. So this direction current was nothing but I2. Clear? Now let us find the value of B. And before finding out the value of V, we can clearly see that I1 and I2 has a negative relationship from this circuit. So I1 is nothing but minus I2. Okay, so let us calculate the value of B, which is minus V1 upon I2. So what is your V1? For V1, you have to write the KVL equation in this loop. So V1 is equal to I1 into 4 ohm minus, there is a dependent source whose value is V1 upon 5. So V1 upon 5, and then it will be uh, it. So let me write it like this: V1 minus I1 by into 4 minus V1 by 5 equal to 0. So all we will get is 4 V1 upon 5 equal to 4 I1. 4 will be cancelled out. So we will get V1 upon I1 is equal to 5. But you have to calculate V1 upon minus I2. So since you know that I1 is equal to minus I2, you can write this in place of here. So you will get V1 minus V1 upon I2 will be equal to 5. So this is nothing but your value of B. So your B value will be 5. Now what is your D value? D value is minus I1 upon I2, right? Yes, it is minus I1 upon I2 at V2 is equal to 0. As since this circuit has already V2 is equal to 0, the same circuit will be used for calculating D value also. And also you know that I1 is equal to minus I2. So obviously D, which is equal to minus I1, and I2 will also have a value of minus I1. So you will get as 1. So your D value will be 1 and B value will be 5. So this is how you can calculate these B and D parameters. So let's move to the last example. So in this example, you see there is a Z parameter 2-port network here, and there is a load resistance which is variable at the output, and there is a 10-volt voltage source with an 1 ohm resistance in series, and you have to find the value of RL so that the maximum power is transmitted to RL and also the maximum power dissipated value. So what to do? Let us write some standard notations here, right? So how to calculate the value of RL so that maximum power will be dissipated in it. So obviously you have Z parameter given, and only one thing comes to the mind, that you have to draw the equivalent circuit of the circuit and then find the Thevenin or Norton equivalent of the circuit. So I think it will be easier for us to calculate the Thevenin equivalent of this circuit, because Z parameter networks are series networks, right? So let us draw the equivalent circuit of this 2-port network, and then we will have to find the Thevenin equivalent of voltage and resistance, which is VTH and RTH, and then we can simply find the value of RL so that the power will be maximized and the value of power, right? So let's calculate the make the equivalent circuit. Now, as you can see, I have drawn the equivalent circuit of this Z parameter 2-port network and connected it with the source voltage and source resistance. And you know that Z11 value, all these Z values are given here. So now what we have to do is, first we have to calculate the Thevenin's resistance and Thevenin's voltage of this circuit across these two terminals A and B, across which this load resistance RL was put, right? So calculating VTH. So how do we calculate VTH? All we do is we have to find the voltage across this A and B terminals, and doing so, we will get the VTH value. So since these terminals are open circuited, because for calculating VTH you have to open circuit the output terminal. So what is going to happen with I2? I2 will become 0, right? And if I2 will become 0, what will happen to this dependent source? This will also become 0 because it is dependent on I2. So what we will get is a circuit where only this I1 current will flow here, and the voltage drop across Z11 will be the drop which will be equal to the voltage drop V1. So let us calculate it. So by seeing this circuit, I have modified it according to our needs, and you can see that this dependent source at the output, which is a voltage source of having value of 3I1, which is dependent on this I1, the value of 3I1 will be nothing but equal to the VTH. So all you have to do is you have to calculate the value of I1 and you will get the VTH. So just apply the KVL in this circuit. You will get 10 minus I1 minus 5I1 is equal to 0. So you get I1 is equal to 10 divided by 6. So this is your I1 current. So what is the value of VTH from here, from outside? VTH is nothing but 3I1, which is nothing but equal to 3 into 10 divided by 6. So you will get 5 volt. So your VTH is 5 volt. Now let's calculate RTH. Now to calculate RTH, all we have to do is we have to deactivate all the independent voltage and current sources in the circuit, and then find out. So we have to draw a modified circuit. So I have drawn this circuit, and this voltage source is short circuited. And since there are two dependent sources in this circuit, we have to apply a generator. Remember the calculation of RTH methods when we were discussing network and Thevenin theorems, Thevenin theorems and Norton theorems. So let us make a generator of 1 ampere here. And when we calculate this value V2, or output voltage between these terminals, then we can clearly very simply calculate as RTH as V2 divided by 1. So whatever the value of V2 will come, it will be nothing but the value of our RTH. Okay. So I have applied a generator of 1 ampere. So I2 value will be equal to 1 ampere. So you can say that this value will become 2 volts, right? 2 into I2, it will become 2 volts. So we can now simply calculate a KVL equation in the internal circuit, because for getting this value of V2, you also need to have the value of this 3I1. So you have to calculate I1. So KVL in input, let me apply KVL in input. So we will get I1 into 1 plus I1 into 5. It will be a drop like this, right? Plus 2 into I2 equal to 0. So 6I1 plus, since I2 is 1 ampere, so it will be 2 is equal to 0. So you get I1 is equal to 2 divided by 6, means 1 by 3 ampere. So you have got your value of I1 as 1 by 3 ampere. So can you get the value of this voltage? So this will become your 3 into 1 by 3, which is 1 volt. So this will become 1 volt. So now to get the value of V2, let us apply a KVL between these two terminals, right? Only between these two terminals. So from here to here, so what, can you tell me the value of V2 just by seeing this circuit? V2 is going to be equal to the drop between this and this voltage drop, right? Because what is V2? V2 is the voltage difference between this reference terminal and this terminal. So V2 is going to be I2 into 6 plus 3 into I1. So since I2 is already 1 ampere, we have taken it into 6 plus 3 into what was I1? 1 by 3. So finally we will get 6 plus 1 is equal to 7 volts. So now you can say that RTH is equal to, this is your V2, right? V2 divided by 1, which is 7 ohm. So you get your RTH as 7 ohm for this whole circuit. So I made a little mistake since here this 2 will go this side, so this will become minus, negative sign. So this I1 will be minus 1 by 3 ampere. As it is obvious, since this is working as a voltage source, this I1 cannot be in this direction. It has to be in this direction, right? So let us make this correct. So this plus sign will become minus, and the 6 plus 1 becomes 6 minus 1. So we will get basically 5 volt. So RTH will become 5 ohm. So we will get our RTH as 5 ohm. Now let's draw the final circuit. So we will have RTH, which is 5 ohm. Then we already calculated VTH. And what was the value of VTH? It was also 5 volt. And you know that for maximum power to transfer, the value of RL should be equal to RTH, which is equal to 5 ohm. So this also will be 5 ohm. So the final current which will be flowing in this circuit will be 5 volt divided by 5 plus 5 is equal to 0.5 ampere. So can you tell me the power dissipated in this load resistor? PL will be nothing but equal to I square into RL. So 0.5 whole squared into 5. So what will the final value? So it will be 1.25 watts. So this is how you calculate answers for such kind of examples. So if some circuit is given other than two-port network, so you have to draw equivalent circuit first. And if the question is relating to calculating maximum power and something like that, so you have to convert the whole circuit into Thevenin's equivalent circuit, and that is how your solutions will become very easy to get. Clear? Thank you.